Okay, now am I being heard? Okay, great. Okay, sorry about that. So anyway, there's been a long running battle out there. I shouldn't say long running. It's actually been culminating more and more these days about to crimp or not to crimp, or is soldering a better way of doing it. I'm going to be talking about some pretty simplistic things, but there's a lot of little subtleties that as we work through it, we'll find some interesting things that we may not all know about. And I'm sure that we can share a few other ideas that none of us know about. So we're going to talk about just simply, splicing a couple of wires together and kind of the right way of doing things, or at least a way of doing things. I'm going to look at Anderson Powerpole connectors, and then we're going to culminate at looking at coax connectors and trying to decide which is better, soldering or crimping. So most hams will consider purchasing tools to aid them in connecting wires. The key thing is they'll consider. Trying to get a ham to spend money, that's a whole nother thing. So let's, as we work through this, we'll take a little bit of a look and see that, well, are you okay with not spending money, or are you better off spending a little money because you get some pretty good paybacks from that? Generally, they start by purchasing simple crimping tools for doing butt splices, and then they continue to take and move on to more advanced tools. Anderson Powerpoles is a good standard for doing power wiring for your transceivers and for your ham check. It's a really cool system if you're not acquainted with it. Coax crimp connectors provide a consistent connection to coax, and we'll take a look and see about why that is and how it might improve things for you. So just a simple starting off with how you take and put together two simple wires, pretty darn simple. So here on the upper left-hand corner is just two wires that you end up stripping off insulation about the same length of it. The key here, the trick here is take halfway down that stripped off piece of wire, put a crimp in it at 90 degrees. That gives you a starting point that you can put the two wires and use your two fingers, your thumbs on both fingers, and use that to wrap that wire around that center conductor. And then over on the right is just soldering. And we'll get in a lot more on talking about soldering. And for this type of connector, you either use like shrink tubing, or you can use tape. There's good and bad about both of them. If you use shrink tubing, you need a heat gun, or you can use the barrel on your gun, on your heat gun, on your soldering iron to take and shrink up that tubing. So simple way of splicing, just two wires, strip the ends off of it, bend the two wires at 90 degrees halfway down the wire, take the two wires, twist together, solder, and add some shrink tubing or tape to insulate the connections. So some people just use tape. Well, there's always a challenge in using tape. That tape always seems to have a finite lifespan, is that it just doesn't last forever. It's going to last for, maybe a year, maybe a two, depending on what the environment is, and then it will kind of lose its longevity there and fall off. So I don't like using tape. It just has a finite lifespan. Good for splicing most any type of wire, not good for very large wires. So when you start getting up into 12 gauge, or not 12 gauge, I should go on the other way, 8 gauge, 6 gauge wire, it gets pretty tough doing that little twisting of the wires and soldering things together, plus the amount of heat that you're using. So wire from 10 gauge all the way down to 18 gauge, good candidate for doing that little twist technique. Generally works well provided you have some basic skills for soldering. And that's a big if. Some people are excellent solderers. They know exactly how to solder, the right heat, the right kind of tools to use. Other people think that they're a good solder, but in reality, they don't do such a good job. And some people know that they're not a good soldering person, and so they're always looking for someone else to help out on soldering, or looking for some different techniques. And we'll talk about some different techniques. So we'd already went through this example here. So another good one for splicing two pieces of wire together is using good old butt splices. So that's a little process where you have over on the left side is basically a hollow piece of wire that you stick in two ends of the wire that you strip the ends, and then you use a crimper to smash that thing, that piece of tubing down against the wire there. So these type of butt splices that I have here actually have a plastic cover on. You can get butt splices that don't have the plastic cover on it. Obviously, that plastic cover is intended to give you some ability to provide some isolation and insulation between adjoining contacts. So butt splices, good for 22 gauge wire all the way up to about 10 gauge. They actually have some bigger splices that go on up above that, but for most of the stuff that we're accustomed to doing, 22 gauge wire to 10 gauge wire is usually what we're accustomed to using. Comes in 3 different sizes. And fortunately for people that aren't colorblind, they are 3 different colors. You have the yellow, which is good for 10 to 12 gauge wire. You have your blue coupler there, which is for smaller gauges. And you have the red one down there for 18 to 22 gauge wire. Now, one of the challenges that you have that if you're doing a big old honking cable that has a whole bunch of connectors, that splicing area can get pretty big and bulky. The nice thing about using this technique is over on the right-hand side, there's all kinds of different kinds of connectors that you can use. There's ring connectors, spade connectors, bullet connectors. There's spade connectors as far as how you slide things into other things. And the bottom row is the regular old butt splices. So it's a nice little method for connecting different wires or connecting wires to other terminals or other devices. So the way you do it, splice or you strip off a little bit of wire, you slide the splice on over in the upper right. You use a crimper to smash that piece of tubing down onto the wire. When you get one side done, you just rinse and repeat for the second side. Some people like to end up putting a little shrink tubing on there because that adds up or gives a little strain relief on where those butt splices are made. If you're using solid wire in there and this gets bent very much right at the butt splices, it tends to end up breaking. So that's why the shrink tubing actually helps out, providing just a little more support for the wire. So let's talk about crimpers. The crimper that's in the very top center of the screen, I'll bet you everybody has one of those things in their toolbox. Well, hate to tell you, but that crimper, the only thing good about that crimper is being able to take screws and trim off the length of the screw to something that's more precise or that you need for the area. The stripping mechanism is pretty pathetic, and the crimping mechanism on there leaves a lot to desire. So on the bottom of the screen, I have 2 ratcheting crimpers. So you can see the jaws in each one of those jaws. They're nicely color coded, so you know what color of butt splice or collars to take and put in there. The nice thing about this is that this is a precision, let's say a precision machine. When you push down on that, it has a ratcheting mechanism. So it applies a certain amount of force to take that collar and crimp and smash around the wire. So when you get all the way to the end of the throw on those handles, it will release and then allow you to take the butt splice out of the jaws there. So what does that do for you? It ensures that you have a consistent splice where things have been smashed down to a particular size with a particular amount of force. So when you're finished with that, you have a precision bond between that collar and the wire. Really important. Now, do you think you can get that kind of precision with the crimper that's up in the upper center? Absolutely not. When you crimp on that, you have no idea if made a good crimp or not. It's a guesswork. So ratcheting mechanisms will ensure, that's on the ratcheting mechanisms on those crimpers, will ensure a correct force for all crimps. It completes a cycle, it completes a cycle until the handle is automatically released. So you keep pushing on that. When it releases, you have applied the proper amount of force to get a good crimp and a good bond between the collar and the wire that you put into it. Really important. So these guys here made all the difference in the world on coming up with a good crimp. And this whole, this 2 lines here, we will follow all the way through the rest of this program here about using ratcheting type of crimpers and what they end up meaning for you. So another big question is, should I solder after crimping? So you have a power connector that you crimped onto a big spade or something you crimped onto the back of your wire there, and you want to know if you should solder that or not. So many people kind of basically say that if you crimped it correctly, there's no need to solder. Well, then there's other people that come along and say soldering fills in voids and improves conductivity. So when you're crimping those wires, you know, those little wires, multi-stranded wires are all little bunch of little round things. So you're crimping those things down and there'll be little tiny voids between all those little strands of wire. So when you solder that, the intent there is to fill those voids, thereby mitigating any kind of impurity, oxidation, contaminants getting in there and causing that crimp to oxidize. So that's the thought process there. So another thing that you have to watch out for is when you solder that, solder a multi-strand conductor, that solder gets wicked up inside that wire. So if it's right close to a connection there, and if it's going to be a connection that gets moved around, that connection actually becomes brittle. And if it gets moved back and forth and around, it will end up breaking, fatiguing and breaking the connection there. So just something that when you've soldered enough, you know what to look for to make sure things don't get wicked up too far back into that wire. If it gets wicked up, you're throwing too much heat, or actually you're throwing too much solder in there, and you're getting things entirely too hot where that solder is conducting way back into that wire. So let's talk about Anderson Powerpole connectors. So these connectors are pretty much a standard. They've been adopted by emergency services. Practically every ham that I know use Anderson Powerpole connectors. So this is how you get DC around your ham shack. So it's intended for low voltage DC, typically your 12, 24, 48 volts. And you don't see anything above that 48 volts being used on these type of connectors. So like in my ham shack, everything is all my power connections all use this particular standard, our Anderson Powerpole. So I can move things around in my ham shack. Everything is consistent. I can connect things up. I like for emergency services, if you bring radios into the use of any emergency services, they always have Anderson Powerpole connectors on it. So you can just drop your rig in, plug it right in, and you're up and running. Really, really like those things. One of the things that's a little bit of a challenge is that when you have 2 pieces of wire that has Anderson Powerpole connectors on both ends, you really don't know which is the source and which is the sink. In other words, which one of those connectors is providing the power, which one of those is connected to the radio. So that's one of the little challenging things that people have, and some people like to end up labeling things so they know where the power is coming from, that is coming from a power supply. So to help distinguish the types of power that runs around in your shack, some people end up stacking them vertical. These connectors are really neat in that you can stack them vertically or horizontal. Picture down the lower left is the normal horizontal, the normal orientation that you have for those type of connectors. So let's say those are all your 12-volt connectors in your ham shack. Over here on your right, here these connectors here are stacked on top of each other in a vertical fashion. So let's say all of these connectors connect up to my solar panels. So thereby you can distinguish and keep separate power from your solar panels and power that you run around in your shack. The other thing on these connectors is that they have an absolute rainbow of colors, all kinds of different colors. Like all of my ground connections inside the shack here are all done using, imagine this, green Powerpole connectors. Everything is always a green connector for ground. So let's talk about how we end up crimping those things. So, or let's talk about what the products are that they provide. So crimping is much preferred over solder. People really, they don't really like using soldering techniques on this. And it gets, you got to be really a precise solderer if you're going to end up using soldering. So everybody just uses plain old crimping, no solder. Need to invest in a quality crimper designed specifically for the task. So in other words, you want a crimper that is specifically designed for doing Anderson Powerpole connectors. You don't want a generic one for different kinds of different sizes of spades and stuff like that. You want something absolutely for that. If you notice in the picture of the crimper on the right, there's kind of a black box on the back end of that. So that's a little piece of cowling. When you place your little crimp there inside there for your crimping, or your spade inside there, you want that all the way to the back. So it tells you that you've inserted it far enough. That's why you always need to make sure it has that little guide on the back to make sure you get the right distance between the crimping jaws and the back end of that little spade there. Spades always come in 3 different sizes, or the contacts come in 3 different sizes. You have the smallest one good for 15 amps. You have the medium-sized one good for 30 amps, and it's good for 14 to 12 gauge wire. And you have the big one for 45 amps for 10 gauge wire. Now, even at 20 amps, if you have a very long distance, and doesn't have to be a very long distance of wire, when you key up your single sideband transmitter, you can get a bit of a voltage drop across those connectors and also across the wires. So just for me, I tend to use the 10 gauge wire with the 45 amp connectors. Anything coming off of the back end of my power supply into a radio uses the bigger 10 gauge wire, so really minimizes any kind of voltage drop or any kind of problems. So all I can say is that's me. That's the way I tend to do it. I oversize things to make sure I don't have problems down the line. So the way that you do it, you normally crimp off the wire. I think it's about 3/8 of an inch worth of wire. Basically insert the wire into the contact prior to inserting the contact into the crimping tool. When you insert the contact into the crimping tool, you always put the slot, always put the slot of the crimp. I'm messing me up here. Insert the contact tip into the proper slot of the crimper. So you can just make sure that you have it sized right. There's 3 different sizes. You got to make sure that you put it in the right size of the right side of the jaws. Make sure the flat side of the contact is down. So that's the important thing. That gets you the right orientation. And then squeeze the ratchet handles until the ratchet mechanism releases. So after you've crimped the darn thing, when you pull it out of the crimper, of the jaws of the crimper there, if that little tongue on there bent up or bent down, don't even bother about trying to insert that thing into the plastic, I'll call it there. it will not line up and will not go right. You can try bending it back into shape. I usually find if I've screwed things up bad enough and bent one of those things, even if I bend it back into where it's supposed to be, later on that thing will fatigue and break off. So when I get one of these, I just clip the ends off. I hate the expense, but I clip it off and go recrimp everything and do it right where those tongues come straight out. So the next thing is now you over on that picture on the lower left, there it shows the proper crimping on how things are supposed to look, and the little tongue sits out. You slide that into the two plastic connectors there. Yeah, got some dogs there yapping. And then slide it into the Powerpole connector. Just a moment. Now, sometimes they go in very nicely, but you have to push them all the way up. That picture on the lower right-hand corner, there's a little metal spring at the very, very top, and that little tongue has to catch behind it there. And as you slide it in there, when it goes behind that little spring there, you hear a click. You physically hear it click. Sometimes they don't, like on the smaller gauges, they don't go in quite as nice. You don't have as much pushing. You could take a really small screwdriver and catch it behind the little collar here and use that small screwdriver to push it all the way in. And that'll make things a little bit easier to get it latched. But once you got it, get it in there and you hear that click, you want to go through there and tug on it. You want to pull on that wire and the connector and make sure that they don't come apart. If they come apart, you didn't get it in there correctly. Go at it again. That's a really important point to make sure that that's a good solid connection the way it's supposed to be. So once you get these guys together, and also I failed to mention, it's kind of visible here in the left-hand picture. There's a couple little rails on there. There's both males and females rails, and these connectors will slide together and they will kind of bond so you can't pull them apart. When you get them put together like that, there's actually a little hole in the center between the black and the red connector. And there's a little dowel pin that you can slide in there, and that locks those things into place so they won't move around. Sometimes those dowels are kind of hard to get your hands on. They don't always come in a kit. You can use a toothpick. Some people can find Q-tips or something like that, but slide something in there that ends up keeping things from sliding apart. So now let's get to the good part. Good old PL259s. For many years, hams have been soldering PL259s onto the end of the coax. Depending on your soldering equipment and your skills, your success may vary. Even if you got good skills, I've seen some pretty good solderer guys that still did not get a good bond on when they soldered things up. Generally, if there is going to be a failure, it's going to be in the process of soldering the coax shield to the barrel of the connector. So you can see where the guy has the soldering iron, you can see a little hole in the barrel part of the connector, and that process is of trying to get the right amount of soldering in there to get a bond onto the shield and onto the barrel of the connector. That's always been a problem. I can't, well, I won't say that this happens all the time, but I've had a lot of times where I've been asked to come over and help someone troubleshoot a problem with their rig, with their amplifier. They can't get a good SWR. They can't get the amplifier working right. It keeps fuzzing out or doing something crazy. And we start looking at things, and I'll grab a hold of a piece of coax there, and I'm able to take and twist that entire coax around in a circle, which inside the connector there. What does that mean? That means that the darn thing never got soldered correctly. I've actually gone through there and reached back there and just tugged on stuff that didn't look right, was able to take and pull the center pin out along with all the coax right out of it being screwed on the back end of an amplifier. So that process is kind of the one that's, you got to be really, really careful if you're going to solder and have to do the thing right. So here comes a bunch of crimp connectors. That's what we're going to be talking about, a different way of doing things where you're not dealing with, you're trying to conquer that problem with how you end up connecting that braid to the shield of the connector there. So up in the upper left-hand corner, that's a crimp type of connector. The little piece of tubing over on the right side, that's known as a ferrule. If you look at the center pin, that center pin kind of necks down to kind of something thinner. This one here is intended for crimping. So there you're going to be crimping the center pin onto the center conductor of the coax. Drop down right below it, this one's a little different in that you still have the crimping of the shield on the back end, but the front of it, you actually are soldering it in. There's a lot of people that actually prefer to solder, and I think it's a better solution to solder that center pin because you get more area that gets soldered rather than here you go back up to the top left. The only thing that's coming in contact with that center conductor is that little tiny 1/8 inch area there that's getting crimped around it, around that wire. So that's my 2 cents. I'm finding more people prefer soldering that center pin. Also remember that this whole technique is good for end connectors, for BNC connectors, for SMA connectors, you name it, all kinds of connectors. You can just do all your soldering with it, or excuse me, just do crimping with it all. So there's been a lot of debate on which method is better, crimping or soldering for coax connectors. Most agree that crimping and soldering are pretty much equivalent. That's kind of my neutral statement there. That gives me some level of neutrality. But it seems that crimping has taken over for hands that are less skilled in solder. So if you're not a real skilled soldering type of person and don't quite have all the necessary equipment to get in to give it a lot of heat and get into that little tiny orifice on the soldering up the shield, this is something you want to listen up to. And even if you like soldering, this is still a good thing to listen up to. Here's something more else to consider. The last bullet, crimping can be performed outside of the house, outside of the ham shack, where there is no electricity. So you're not using a soldering iron or in difficult conditions. So if you try soldering when it's raining outside or it's windy or something like that, or you're up on top of a tower, it's no fun handling a soldering iron up there, or even if you have one of those butane soldering irons, it just doesn't work. So this is a technique that you could use in all weather. Okay, let's take a look at what we need for tools. So again, if you have quality tools, it makes a big difference. So consider the Quicksilver Radio Deluxe crimping kit. Now understand this guy here is not cheap. Any of these tools here are not cheap tools if you want something that works right. So that's an expensive kit, but it has everything that you need in the kit, and it's a nice thing just to have when you're at field day or at 7QP or wherever. You want a full cycle ratchet crimper. Remember that there are all different sizes of coax, and just because it is that, you know, the LMR 400, that's one difference, one size. You think that the regular old, the fat RG8 is good enough for it, but there's different kinds of RG8. There's 214, there's 213, there's all kinds of different sizes. So one set of jaws is not going to get you all different sizes of coax. It's fine if you standardize it something, but if you want to be able to handle all different sizes, you need about 4 sets of jaws that have varying sizes of crimp ability. So just remember that one size doesn't fit all. want to look for a kit that has multiple sizes in there. You want a stripping tool, very, very important as far as getting the right crimps or getting the right amount of material taken off and to be able to handle different size coax. You want a high grade cutter. This is just for cutting the ends off of or cutting the right length of coax that you want. You want something that doesn't crush the coax. You want something that cuts through the coax. So you'll want a good high grade cutter that makes a difference between having a cheap cutter that you maybe use for house wiring and having something that's intended for cutting coax. The next thing you want to look around for good high grade PL 259s, 239s, whatever you're soldering in type of connectors. That's the right size for the coax and that provide for crimping. One of the things I was looking around at the other night, I run out of Crimp P259s. And I was going to buy some, but I'm used to paying $2, $2.50 at the most for really good high grade connectors. Out there anymore, I mean, it's like for getting high grade stuff, you're paying $5, $5.50 for those darn things. So just be aware that prices have gone up. Okay. So let's go through the process of crimping. So whatever tools that you end up getting, and we're just about at the end of here, got a couple more slides. So make sure that whatever crimping tools, the cutters and strippers and stuff, read the instructions and understand that a lot of times for your strippers, it requires that you do a little adjustment to get the cut for the razor blades that are in there at the right depth. So it does take a little bit of work to get everything calibrated, but read the instructions first. So the first thing you do, just like regular old coax, that screw-on connector, you always slide on first. So in this conditions here, you slide that ferrule on, that little tube type of thing. You slide that onto your coax first. Then you're ready to start work. So using the coax stripper, run it around on that, whatever it needs to end up cutting off the jacket and opening up the dielectric there and exposing the braiding on the inside. So take that braiding, pull back, open that up, pull the braiding back so it's against the shielding on the outside of the cable. Then insert the old connector onto the housing, or connector housing onto the coax. And one of the things you want to do is make sure that when you do get it on there, that center conductor of the coax is extending past the center pin on the coax connector. You want just a little bit of that little center pin sticking out of that center pin on the connector. That means you got room there to take and crimp it or to solder it. So here's a little bit of a couple drawings. So this is Crimp type of connector here in the upper left. This is the guy using the stripper that he rotated around the coax that cuts all the insulation and the dielectric off. This on the lower left is where the guy's fanning back the shielding. And then here he slid the coax connector onto the coax itself. Note that the little center pin of the coax, it's sticking out beyond that center pin there. You want to make sure you have a little bit that's sticking out there. Okay, so trim off the center coax conductor. So that little center pin there that's sticking out in the pitch on the right hand, lower right, you just snip the end of that thing off right flush with where you're going to crimp it. Then you go through there and crimp the center pin. Or if you prefer, solder it if you use solder type of connectors. Slide the ferrule up to the base of the connector, fold the shielding wire back. You grab the crimper, crimp the old ferrule under the outer jacket. So you're crimping, when you're crimping them, you're crimping the shielding onto the connector, and there's a little bit of overlap that is also taking the jacket on the coax and getting it into the ferrule that gets crimped together. You want just a little bit so it holds it together, and then you're done. Now, what I tend to do is, just for an added touch, along with that ferrule that I put on at the very beginning, I usually slide on a piece of shrink tubing. So when I get all finished, I slide that shrink tubing up, get it with heat gun, shrink it down, and that provides a little extra strain relief right there between the connector and the coax. And that's just a nice added touch. And if you buy any cable pre-built, they do this little touch. They add that little shrink tubing on there just to provide a little bit better strain relief as that connector goes on to the coax. So, this upper left there is just showing the crimping process there. The upper right, that's just showing how it gets a neck down and after it's been crimped. The lower left just shows the crimping process of that ferrule onto the back end of the connector. And then the lower right just shows the final product. Sorry that these guys aren't better shape as far as clarity and focus on it. Okay, so let's wrap things up. If you're challenged when soldering two wires together, you might want to consider using crimping techniques. So if you can't get two wires soldered together, I think anything out there, you'll probably want to just move over using the crimping techniques. And I really like using the crimping stuff these days. Anderson Powerpole connectors are the de facto standard for DC power connectors for ham radio operators. Just everybody I know that I can think of pretty much uses the Anderson Powerpole stuff. Now, there are a whole group of people that use vacuum tube radios that this doesn't apply for. So they're used to just taking those radios there and plug it into regular AC. But for modern radios that typically use the 12-volt supplies, Anderson Powerpoles are the way to do it. Crimp connectors can be used outdoors when you don't have access to AC power for soldering, or they can also be used, I should say, or they can also be used in bad weather conditions or in places that you just don't want to be fiddling with a soldering iron, like up on top of a tower while you're trying to replace a PL259. Okay, bad solder connections with coaxial braid is the #1 failure for coax. So just remember that, those solder connectors, if you're going to have a failure, better than 90% of the time, it almost always comes down to some connection back to the braid. And I've seen, compression type of fittings. I've seen all kinds of stuff, but it usually gets to that grounding or that connection to that braid. Using crimp coax connectors will significantly reduce coax connector problems. They just pretty much, all the problems that you've had with connectors on coax will just disappear by using crimp type of connectors. Always use quality tools for crimp connections. Actually always use. I mean, they cost money, and the last bullet down there, quality tools cost dollars, but will save you precious time and reduce problems. When you're in a contest or you're out at 7QP, you don't have time to end up troubleshooting things. Whatever you pull out of your toolbox, you want everything to work the way it's supposed to work. And so when you use good tools for doing these type of connections, you just don't have a problem and problem solve. And it's just a whole lot easier to take and use the right tool for this type of stuff, and problems go away and you don't have to waste your time. Anyway, that's it, guys. I will bring it back and wanted to see if there are any questions or anything that anybody else would like to talk about or share your using crimp type of connectors.
More of a comment on power poles, Mike. If you need more than 45 amps on Powerpoles. What we do on some of our 5 kilowatt amplifiers is we double them up. There's actually a connector that Anderson makes where you can have like a quad of them. So essentially 2 glued together. And we use that for the high voltage supply on the bias of some transistors on our 5 kilowatt amplifier project. So it's 65 volts at, I think they're running 50 amps or something crazy into those finals.
Okay. Wow. Yep. Yeah. I didn't mention that we're doing really heavy power stuff. They have, I've seen them where they've doubled up on them. I've also seen, there's another class for 100 amp and 250 amp. So there's a whole nother class of those Powerpole connectors for really big stuff. Like if you have a winch on the front of your truck.
I've seen them. I think what is it? It's not DC Power, but PowerWorks has some of the bigger ones for connecting like batteries and big supplies and stuff like that. That then they fan out into the little ones after that.
Mm-hmm. So I'll throw out one other thing that came up in another discussion along this line was some of these tools get pretty expensive after a while, and you don't use them all the time. So I've seen several of the clubs talk about actually acquiring these kinds of tools and then checking them out to individuals. So like if you're doing a wholesale upgrade or rework in your ham shack, or you bought a 1,000-foot reel of LMR 400 and you're redoing all your coax, you can check out the tools and then do your work and then bring them back. And then so that's just part of the club membership. So just something I'll throw out. Any other questions?
Well, I'm gonna tell you, Mike, you hit it spot on when the going gets, when you're trying to rely on your coax and all your equipment for that matter. It's probably going to happen at the worst possible time because that's how Murphy works. I had been working the Pennsylvania QSO party. I was responsible for the hex beam on 20 meters. And wouldn't you know, the connector that worked a week ago at the top, which would fed the top of the hex beam, lost its braid, and eventually after strain also lost its tip. So I made 20-meter contacts on nothing more than leaky coax.
Wow. And the other thing is that I didn't really point out, once you've done about 3 of these crimp type of connectors, they go really pretty fast, where if you have a failure, you can probably do that in less than 10 minutes. If you're soldering that kind of stuff, you're going to be 15 to 20 minutes per connector on that if you're going to do it right.
Well, and Mike's got to make sure that all of his stuff works at 7QP, because Anna's going to have something that's screwed up that he needs to help her with. So, there's got to be that sort of consideration in the whole deal.
Okay, I'll bring up one other thing here. This guy here, I actually have some LMR 600, and so this is the size of connector or crimper that you need for 600. So I can stick my finger all the way through the thing. So I had a special project that I needed a coax that ran at extremely high frequency, and it was a 137 foot run. That's because the price of that, I had to measure it out just exactly right. And that those connectors there were $37 a piece for each one of those. So when you did the connection, you had to do it absolutely right. And I was scared crap. I was really scared to do it, but everything went together exactly, precisely. All the cuts and everything were just spot on.
You didn't want to run hardline for that instead?
No. LMR 400 and actually LMR 600 is actually replacing hardline these days.
Scott has a question, I think.
Yeah, Mike. Yeah, great presentation. A lot of good points. I was going to say I have a lot of experience with both, and absolutely go crimp if you can for a lot of reasons. I'm a firm believer, yeah, if we, for 7QP or if you're doing any kind of remote work, bring along the crimping kit, and that includes the stripper and the whole bit, and the extra PL259 crimp types that you're going to need for your particular coax, just in case, right? Because we just, like Paul was talking about, you were talking about, and Anna was talking about, just have them there just in case. The other thing is on the soldering side, I bought over the years, every time I went to a Hamfest, I'd buy a bunch of the solder type, PL259s. So I've discovered, and you might have mentioned it, they've got the nickel or the nickel coat. I don't think they're nickel plated. Are they nickel plated steel? And then you've got the silver plated steel types, right? Which are obviously the more expensive ones. But the soldering, if you're going to do any soldering, you want to do it on silver plated, because the nickel oxidizes as an oxide layer, and it's very difficult to solder onto that oxide layer. I understand that some people say you have to actually file it a little bit first, where you're going to actually do the soldering right before you solder, so there's like a fresh nickel layer exposed. But the best way to do it, and if you're going to go the solder route, which I highly do not recommend, is to use silver plated ones, and then that way you can maybe do it. And then it takes a lot of the learning curve with those is high. You have to worry about melting. If you apply too much heat, you're going to end up melting the center, the dielectric in between the shield and the center conductor, and all those kinds of problems. And you'd be very frustrated unless you've done a lot of this stuff in the past. So anybody who wants to do their own coax, absolutely just go crimp. And even if they're more expensive now, like Mike was saying, I think they're $5. Although I think just at Rick Riel the other day, that what's that? When you first walk in and they got that those guys that sell all that stuff, they've got 1 million connectors. I think they're still selling them from the range of even the good ones in the $250 or $3 range, something like that for those still. Probably because he bought them a long time ago. But anyway, that's my 2 cents on that. But very good presentation. Thank you.
So Scott, have you ever tried soldering to a connector that's been chromed?
No, I don't. Well, are the nickel plated ones chrome plated? I don't know.
No, that's it. There's another class in there where they actually do flash chrome plating on it.
No, I don't know if I've tried those. I don't think so. Nothing that shiny.
First of all, chrome is a poor conductor.
Yeah.
Second of all, you can't solder to chrome.
I didn't think you could.
But I was at a friend's or guy's ham shack, and we needed to redo some connectors there. So he had a handful of these chrome solder connectors that were chrome. I said, "You're going to be," and that's the problem. But he had tried soldering one up, and the braid wasn't making any continuity, any connection there. So I took a look at that and I said, well, these are crap connectors. I didn't quite say it that way, but I said, these are problem connectors.
Sure.
And I explained why. And he said, oh, well, I got a whole bunch of these things here.
Yes.
What can I do with
buying
them?
a bunch of them, yeah.
Yeah. So, that's the other thing to watch out for. Don't buy connectors that are chrome.
Yeah.
Chrome plated. They look nice, but they don't solder.
Yeah.
I'd also
like
to mention, for the really, really, really lazy like me, ABR Industries will make up if you know what length you want, they will make pre-made cables for very reasonable prices. So I don't even bother making jumpers anymore. If I've got a jumper, I will order a 2 or 3 foot jumper from ABR with exactly the connectors I want, tested assembly. And even for 7QP, I just ordered an 100-foot cable with whatever connectors I wanted at the end. They put the shrink tube on them. They will even put labeled shrink tube on them for you. You can pay like $5 extra for the cable, and they can put your call sign on the cable so that nobody takes off with it. Because Mike's really good about that. He always is throwing my cables in his camper, and I got to get them back from him. So he's just that.
That's because you buy the good stuff, Anna.
Yep.
Well, that's probably the best suggestion of all, because then you're going to work. You don't have to
You
worry.
can also, even if you don't know exactly what length and you want to be lazy still, like me, they will actually do one end that is not terminated. So you can order one end not terminated, the other terminated, run up the tower with your 250 foot, you buy some extra, and then only terminate the one end. So yeah, there's some laziness that can be done in there. I think that there's another company that does the same thing, but I've ordered from ABR and I've had good luck with them, and the cable assemblies look good.
Well, if you got that connector on top of a tower, you definitely want to make sure that there's not a problem with it.
That's the good one.
Yeah. Yeah.
Yeah.
Oh, I had so
Very
many
nice.
soldered ones that you just had to throw out because just like Mike said, that you like you think it's well soldered and then all of a sudden you just twist it and it twists and it's like, this is junk. The other thing is some coax, you have to be aware if you buy your own coax, without connectors on it, get the good stuff because I bought really cheap like RG58 and the braid is so thin that when you try to pull the braid back over, even on a crimp type connector, there's like maybe 2 strands or 3 strands that actually connect or touching the connector, and it's useless. So get the good coax. It has a good braid.
All right, so if anybody's been monitoring the chat, Andy asked about ABR. I put out the website, but they also sell through many of the dealers, DX Engineering, I think, at minimum HRO, for sure. So anyway,
if you want
great
the standard,
discussion.
if you want the standard cable assemblies, that's great. If you want something custom, you go through their website and they do give a ham discount. It's like 5 or 10% that they kick off the cable assembly for custom assemblies.
Good to know. All right, thank you, Mike. Always learning just valuable information, either from experience or just sharing the knowledge throughout the different topics. So thank you very much for doing that.